Thanks a lot. Thanks. Hi, everyone. Quick raise of hands to begin. How many people here are playing or working, managing Kubernetes clusters? Well, I hope everyone, otherwise you wouldn't be here, I guess. How many people are working or living on a farm? Oh yeah, there's a few hands. Cool, we can have a drink afterwards. Perfect. So let's start with the presentations. My name is Clément Nussbaumer. I work for Post Finance since 4 years now. I'm managing the open source Kubernetes clusters there. And I'm a Golang enthusiast. I play music in a brass band. And I married my wife, who happens to be a farmer on a Swiss farm in Switzerland, where they have 65 milking cows, they have chicken, 250, we produce eggs, we produce flour, we produce a lot of stuff, and we also have a biogas plant. But I will get to all of that in a second. And on the right, you have a picture I took on Tuesday with one of the cows, and obviously I had to pick the cow which is named Jura, because I'm from Canton de Jura. So, the challenge we face on a farm is that there is lots of stuff to collect, lots of data to incorporate. It would be really useful to have all this data in the tools that we use and that we know, like Grafana and so on. And well, farming evolved. It's no longer like this nice oil on canvas painting from 1883. We have lots of tools, which, like we have a milking robot, which is a super state-of-the-art machine installed last year, which it produces data, but we cannot get the data. The data is in some old Windows application. The database, you don't want to look at it. And well, for the dashboards, you can just try to do a VNC on the Windows machine, and that's not really what I want to have for the farm. Also, alerting is quite limited. You just have what comes out of the box with the software, which means not much. So yeah, it's not that bad. It's getting there, but yeah, compared to what we use, it feels a little old. So yeah, we want to improve that. First, a few words on the farm. So the farm is on two sites. So on the left-hand side, we have the main site where we live, where the milking cows are. So those are Holstein cows. It's in Porrentruy, for those of you who haven't recognized the castle in the background. And that's where we have the milking robot, the cows, the milk vending machine, and everything. And on the right side, you have the biogas plant site, which is like 5 kilometers away. Porrentruy would be like here compared to the picture on the right. And that's where we produce biogas, which is basically methane that we can then use in our case in some modified diesel engines to produce electricity and also residual heat that we also use there. So that's the big picture of the farm. So we have two sites, and we have the milking site where all the cows are, and so we have the milking data in there. And on the right side, the biogas, where we'll have also some monitoring to do, as we'll see in an instant. But first, I want to talk a little about the biogas, because how many people here are familiar with biogas and lager or biogas plants? Well, really a few people. So it's really great. It's something that it started in 2006, I think. The idea is not that complicated. The cows, they produce manure. You transfer that to the biogas plant because it's not on the same site. And then you insert this manure, liquid and solid, into the digesters. Digesters are huge pool of liquid manure. You don't want to fall into those, otherwise you're instantly dead, I guess. Those are heated to 40 degrees Celsius. When I mean huge pools, it's 1,000 cubic meter per digester. So there's the first one and the second one. Those are called Nargerer, I think, of Deutsch. So you have those digesters, and then you have a reaction which happens and which produces methane. It's the same that happens in a cow's belly, but instead of producing useless methane, which ends up as farts in the atmosphere, we can reuse the methane and we can use it in two engines. Relatively big engines, I would say. The size of the engine is around the size of this stage here for one engine. And those produce a lot of electricity and heat. And so the electricity we can sell, same goes for the milk produced by the cows. And then the heat produced by the engines we can reuse, first of all, to heat the digesters, because they need to be at 40 degrees when you have to heat up 1,000 cubic meters of material. It's takes a lot of energy to heat that up. So we reuse the heat of the engines. And also, when we have, because we also have crops like wheat, corn, and everything, we can use the excess heat to dry up the crops before selling those. So then we don't have penalties because the crops are too wet, which is something that often happens otherwise. And so that's not all. The digesters, once the manure has been went through the digesters, you collect it. There's a solid and liquid digestate that you can use. You use that as fertilizers on your fields. And so in the case of my wife's family farm, they have completely stopped actually buying fertilizers from the industry. They can just completely use the fertilizers produced by the biogas. So it's a closed loop, which means that you can save lots of money. And so you use this digestate as fertilizers on the farm soils. You grow crops which produce revenue, and the crops also you feed the cows with it. So that's a little how the farm works from like a diagram perspective, like we IT people like to see. So now let's turn the farm cloud native. Let's see what we can do to actually incorporate all of this data and turn it to something that can be useful for my wife and her colleagues. So before doing that, well, you can have a look at the meme. I like it. It's a fun one. I will talk about my infrastructure foundation because I want to run some workloads. I need some servers to do that. And what I picked actually is just old PCs under a desk. I just have 4 HP Elite Disk Mini PC, which are quite silent, except when you run too much workload on those. And you can get those for quite cheap. Like one of those nodes costs $250. I buy 1 new per year, so then I can recycle, and if one falls apart, I just have enough and I can rotate like that. The electricity cost, I installed the power meter. I consume precisely 1.4 kilowatt hours per day for the entire clusters, which is really not much. The cost per year is only $140. That's not that much if you compare to what you would pay to get the same on a cloud. It would be much more than that. And it's much more fun as well because you have it at home. Yeah. So that's what I use to run all the workloads. And then I got inspired to do that by, I think it was Billy Mack that did a talk at some KubeCon a few years ago. Well, it was called Kubernetes at Home back then. Now it's called Home Operations. But the idea is that those guys here, mainly Bernd and Andro, they have developed an entire ecosystem to help you run your home Kubernetes cluster. So they provide tips. There's a whole community. There is a Discord channel where you can ask for help, and they guide you towards having your own cluster at home, which is a lot of fun, and it also helps a lot because you can, like, OneDrop, that's his repository where he manages his cluster. So he uses GitOps approach to manage a cluster. And if you follow what he did, then you will spare a lot of time because there's a lot of already automated renovate pipeline or Dependabot or whatever tool you use to automate your updates. Basically, you can get a cluster working in a relatively short amount of time with automatic updates and everything. So yeah, a really cool project if you want to have a Kubernetes cluster at home and you don't know where to start. I think this is where you should have a look. Then, what am I running which operating system to use for my nodes? I was using Ubuntu, but switched to Talos Linux because it's tailored for Kubernetes. How many people use Talos Linux in this room? Okay, and how many people have heard about it? Well, okay, cool. Then it's gaining traction. I like that. Well, I guess most of you have heard about it, but I will still explain a little how it works. The idea is that you don't have an SSH server, or there is no OpenSSH daemon running or whatsoever. The configuration, the way you configure your Talos Linux nodes is through an API endpoint on port 50,000, and you establish a mutual TLS connection to the endpoint, and then you send YAML documents to configure your Linux machine. So no more netplan, well, netplan would be YAML, you could say, but no more going into the systemd files to start a service or whatever. Instead, you have a large machine configuration document, which is a big YAML, which contains all what the Talos Linux operating system needs to run. And so you have this machine document, you customize it, you send it to the machine, and that's it. Basically, then you have controllers inside the, well, Talos is a bunch of controllers in the end. You have those controllers like machine D, which is going to take a look at your machine config and apply the change. So if you change the MTU to 9000, for example, the network reconciler will take a look at the MTU change and will apply it on the IP link, so on the Linux interface. So that's how Talos Linux works. It's really fun to work with, and it spares me a lot of time because I don't have to do an apt-OS update, upgrade, or whatever. I just run Talos, and if sometimes I have to update the OS, it's just Talos CTL upgrade, and it takes like 5 minutes, and it's updated. So yeah, I really like it. If you want to know more about Talos, a small plug, on the post-finance stand, we are running a Talos demo during the day. Throughout the day, we are deploying a cluster, resetting a cluster, and yeah, this can give you an overview of how it looks like. And I'm also giving a course on Talos Linux for the Let's Boot company. So if you want to get to know more with Talos, well, just you can do that. Then the network architecture. In the description, I mentioned that I have like free load balancer. How do I do that? Well, IPv6. How many people are using IPv6? That's not enough. It's 2025. We need to increase that number. Well, I hope I can give you a good reason to use IPv6 at home. Well, first of all, I'm glad I'm having an Init 7 copper connection. That's really wonderful. Works all the time. The speed is not a fiber, but I live in Porrentruy. You can't have all the benefits when you live on a farm. But that's still more than enough that I need to run all my services, so that's fine. So I get a /48 prefix from Init 7, which means that I get all these IPs in this range, which is like, I think 10 to the 28, so more IPs than I need. And how do I use it for my cluster? I configured my router so that, or I configure MetalLB in layer 2 mode, so in layer 2, typically when you have layer 2 load balancer, you ask for an IP, and then you have an ARP response, address resolution protocol, which says, okay, for example, node 2, I'm responsible for this IP address, so send me the traffic. So that's how ARP works for an IPv4 address. And IPv6, you have the same mechanism. It's just called Neighbor Discovery Protocol, NDP. And so when you make a request to this IP address, which is the actual one, you can try if you have IPv6 on your laptop, which is not going to be the case with the Wi-Fi of the Migros, I guess, or not from the 5G hotspot, but whatever. So when you want to reach this IP address, you reach my router, my MacroTik router, and then it asks on the network who is responsible for this IP address. And then one of the nodes, the one which is responsible, there's a leader election, is going to reply, okay, I'm responsible for this IP address, so it sends its MAC address, and then the router will forward the packet to that node. And then if the node goes away, then there is going to be a new leader election, and the next node is going to pick up the IP address responsibility, and then is going to send its MAC address when it needs when it gets a packet. What's the advantage compared to doing that with IPv6? Well, why do we want to do that with IPv6 instead of IPv4? Because IPv6, you get one IP. Well, you get as many IPs as you like, so you don't need to mess with port forwarding at all. You can just use the internet address here on port 80, and that's it. You're on the service. Whereas with IPv4, if you try to do the same, you'll have to configure port forwarding, destination NATing, and everything in your router. And it's much more fun to do it with IPv6. And then you have zero cost, high availability. The failover is just free of charge. It's just a layer 2. Next step would be to do it with BGP, but it would be the same idea. So yeah, that's how I implemented the load balancer after some tries. First of all, it was Cloudflare. I was paying 5 Swiss francs per month, so it would go to either one of the nodes. But yeah, so I think it's much better like that. So I run some workloads. This is my actual cluster, not that big. IKEA shelves and 4 nodes, super reliable actually. And I want to store some state on it. Kubernetes is kind of stateful nowadays, you can say that. And so I run mainly the database and Victoria Metrics as time series database, as we'll see in an instant. And I use Longhorn for the replicated block storage, just because it works out of the box. I didn't want to search too much. It was easy, has a nice GUI, does the job for a home app setup. And it's quite cool to have replicated block storage because I can just pull the plug out of a node and basically nothing happens, or at most there is some new pod starting, and for 1 minute I have some downtime, but that's really not much of an issue. And then if you host data, you need to back it up because, well, I'm not multi-region, as you can imagine. So I really need to have proper backup. So for that, I use Velero. I do volume snapshots, then I copy the data to an S3, or actually to 2 different S3 providers. And I also do some database backups. For that, I just implemented the simple cron jobs, and I run MariaDB dump. I pipe that to gzip in asyncable mode, which makes it so that it only modifies the changed blocks, and then Rustic can do an incremental backup. I did a small blog article on that, but I'm really happy with that setup. I'm confident that I can, even if the house burns, I hope it doesn't happen, but then I still have the data, which is quite important because there's more than just the metrics data. So let's check the time. Okay, good. We are on track. My monitoring stack, I'm using Victoria Metrics. How many people use Victoria Metrics? Oh, well, that's a minority, I say. I see some post-colleagues as well. No surprise. If you don't need it, I mean, if you're fine with Prometheus, well, you don't need to listen. You can take a nap for the next 5 minutes. If you are bothered with the resource consumption of Prometheus, perhaps it's time to pay attention. Why I use Victoria Metrics? Because the architecture is simple. I really like the fact that it's simple. You can explain it to a 5-year-old, he should understand. So you have the I hope. You have the storage nodes where you store the data. You have the inserters, which push the data to the storage nodes, and then you have the select nodes, or select pods, or whatever, select instances, which are going to query the storage node. So if you want more storage, you increase the number of storage nodes. If you have contention on the insert side because too much CPU, you just increase the number of inserters, and then they have a nice Victoria Metrics operator which does everything for you, all the routing and all the piping. So actually deploying cluster like that doesn't take time. You can also check my repository, my home operation Git repository, where basically it's a manifest where you describe, okay, I want 2 inserters, I want 3 storage nodes, and that's it. Then I have something a little more complex because some of the data I want, so basically I'm running 2 clusters, 2 Victoria Metrics clusters to store the data, because I want one which is for the short-term data where I push everything into it, and I want one long-term Victoria Metrics where I want to store, for example, the milking data that I want to be able to look 10 years in the past. Hopefully in 8 years I can do that, and see all the data accumulated throughout the years, which is quite fun. So for that, what you can do, you can run 2 Victoria Metrics clusters. That's what I did. So you have the short-term cluster, which has a 3 months retention period, and then the long-term, which has a 10-year retention period. Then I modified Victoria Metrics agent, which is the collection agent. I modified it a little, or I just added a rule that says, okay, if there is the retention period long-term label on a metric, you should also send it to the long-term instance. So it will, all the metrics go to the short-term, but some of the metrics go to the long-term where they are stored forever. And then there is a Victoria Metrics select. You can put it in front of both clusters, and it will transparently grab the data and deduplicate. So you don't need to bother or to know that there are 2 clusters. You don't even know about it. Except when you query more than 3 months in the past, then you will only see the data from the long-term instance. So that's how I do it so that I can keep the metrics for a long term. So I've introduced you to my tech stack, and I've given some hints on how you could replicate that at home. So now let's check the use cases that we have on the farm. I've identified 5 use cases, the 5 most important. Well, the first one being the milking data. We have this fancy Delaval robot that automatically milks the cows, which is a small miracle every time a cow gets in. No, it works really well. It's a miracle to watch. That's what I meant. Then we have the biogas plant. We have some electric fences because, well, the cows, you don't want them running around, so you need some electricity in the wire that they don't escape. And then the milk vending machine. We have a self-service shop where we sell milk, and we want to know how much milk there remains in the tank. And then the invoicing solution, we'll get to that in the end. let's start with the milking robot. So that's a picture of the robot, obviously. We installed it, I think, in December of 2024, so it's quite recent. It's an engineering marvel, works really well. There's basically some cameras and perhaps LiDAR as well, I'm not sure, on the arm that detects where the teeth are. Then the whole thing moves forward, takes the pipes with the device to attach to the teeth, and it starts milking the cow. And when it's over, sometimes there is some dirt on here, so it goes on this thingy here, which is just a sponge, and it rubs against it. It's fun to watch. So the milking robot works well. It's fun. It's nice, but the software is like, yeah, yeah. Well, it does the job. But yeah, it's a Windows application, and I prefer not to use it too much. Well, obviously no API access. Limited mobile access, to be fair. There is some, but there is an application which is old, but it does the job. You can still monitor a little. It's already much better than what was there before. As I don't think I have included it, but before it was really a crappy old software, 25 years old, and well, it did the job, but yeah. So it's not that recent. We want something better for the farm. So we have to write a solution to extract the data of the milking robot. This time, luckily, compared to last time, well, to the previous milking data system, the new one installed in December 2024, it uses a Microsoft SQL Server database. So luckily, there's also some Golang tooling around that. And so what I did is I built a Del Pro exporter. Del Pro is the name of the software, so I built an open source an exporter, and I just put like some code snippet of what it does on the background. Basically, you query the database. Well, the actual query is more like this long. And then you get a series of records, each record being a milking event. And for each of those records, you are going to create some gauges or some counters in Victoria Metrics. Or in Prometheus, it would be the same. I'm exporting Prometheus exposition format metrics. And so for each of the cows, we have counters that track how much milk the cow produced, and which increase whenever there is a milking event. So because I did that only 2 weeks ago, I had to implement a historical mode export whereby you can do a backfilling of the data into Victoria Metrics. So who was aware that you can do that? With Prometheus as well, you can actually backfill import data. And I only recently learned about it, so that's something which is really cool. If you want to, like here, typically I have 6 months or even more worth of data that I want to push to Victoria Metrics, but I didn't have the exporter when we received the robot, so I run this historical metrics mode, and then it produces the same metrics that you're used to seeing in the /metrics endpoint, except that there is a timestamp in milliseconds at the end, which is the timestamp of the time series record. So that's how I was able to backfill and import all the old data into Victoria Metrics. I don't want to. Okay, that's still fine. And thanks to that, you can have a nice Grafana dashboard. So we see I put on the right-hand side the stats of my favorite cow, Jura. You see how much milk it produced, how much time each milking took, so between 5 and 7 minutes for her. And cells, that's an indicator of the milk quality. You don't want too many cells in your milk, otherwise, well, it's a sign of not so good health for your cows, or it's also something that will be used against you to penalize you, and you will get less money for the milk that you deliver. So this is an important indicator. And on the left-hand side, you have the trends that on the farm. So how much cows was produced per cow on average over the last 24 hours. Again, the cell counter. Then the incomplete milking events. So that's when a cow is like a little stubborn or whatever, and she just slaps the robot away. And so sometimes they are not completely milked, so you need to check and make sure that, for example, Jet Set 72 should perhaps be checked. Perhaps she is too stubborn and we need to milk her manually at some point, or perhaps she is just injured and we need to check. So that's what we get Those are the metrics that we get. Perhaps I can also show it live. It's maybe more fun. So that should be around here. So yeah, so that's how it looks like. We also have some data regarding the how much, like the average milking duration, and also the P95. Well, it's absolutely useless to know the P95 in our setup, but it was fun to replicate that. And then the heat map, I still need to work on it. It's not that pretty because there are not that many timestamps actually. If you consider that there is one milking robot for 65 cows and it takes like between 5 and 10 minutes per cow to milk, you just have like not random, but you have like individual milking events here and there. So there's not really enough data to show it properly on the heat map. I think when I zoom out a little, let's see if it breaks. No, it's a little better. So we get still an idea of how much time it takes to milk the cows, and perhaps on this day here there must have been some incident or an issue on the farm, or perhaps too much noise or whatever that disturbed the cows and made them take longer to get milked. Yeah, and then you can pick for the cows that you are interested in. So I already chose 33. You can see how much milk she produced. So I think that's the first one here. Yeah, she's in her second lactation and 357 days in that lactation, and she's producing still a reasonable amount of milk. So yeah, that's the first use case that we have on the farm. Let's move on to the biogas plant. But I have to drink a little bit. I'm not used to talking that much. So that's how the biogas plant looks like from the outside. On the left-hand side, you have the picture of the green thingy in front of the... So the big thingy is the digester, where the 1,000 cubic meter digester with the methane in there. The methane is actually what makes the foil or the membrane go up. And then you have the mixer, which is where you insert the solid manure, which then gets threaded, and then there are some screws, horizontal and screws that push the thing inside the... I can even use that. So there is a screw here and another one which pushes the mixed manure into the digester, in the first digester. On the top, you have the control systems, which we changed, I think, 5 years ago. I was a little afraid. It was the original one was already 15 years old, and there was no backup at all. And if it fails, then the entire biogas plant stops completely. Those are really reliable machines, but I wanted to do like proactive maintenance, and so we bought a new one which had a network interface. The previous one only had serial interface, and I'm quite happy that this one had a network interface. As we'll see in an instant, it was much easier to get the data from it. And this is just the inside of one of the engines. So I think that's a six pistons engines. Those are basically huge diesel engines that have been modified by some companies so that they run on methane. So, well, you have to filter the methane first and everything, but then you can actually burn it in an engine, and it's really powerful. The important metrics that we want to know about are like how much stuff is inside the digesters, which temperature the digesters are running at, and how much electricity are produced by the engines, and finally the pressure below the membrane. Because if there is too much pressure at some point, then it will just open up. You have a lot of methane in the atmosphere, which is not good, and then you have also to go on the digester to replace the membrane, and it's not an easy job. It's physical. You don't want to do that too often. So some of the metrics are quite important to monitor. And so that's the magnificent GUI that comes with the software. It does the job. To be fair, I'm not there yet to have a visualization that shows everything like this one, because here you have everything: the two digesters, the input mixer, then the output zones and everything, the power generation. I don't think we are going to replace that one. However, if you want to do a graph of the electrical production of the motors, it's going to look like that. And this feels a little old. And if you want to remotely access it, you need VNC. Well, I created the WireGuard. So I installed the WireGuard router on the biogas plant, so they can safely remotely access the interface. But it's still not what I would like to do. And the most problematic thing with this whole automation controller is that there's no way to write a custom alert. So you just have to rely on what's built inside the software. But if you wanted to alert, for example, that the gas, the pressure of the gas, of the methane inside the digester is going too high, there's no way to do that. So you have to constantly monitor it and make sure that it doesn't happen. But we'll see in an instant that we can improve that. And so those controllers, those automation controllers, they are the company which manufactures those is called Saya, and the way you can communicate with those is through the Saya SRS bus protocol. I don't know too much about that protocol, unless that it's UDP post 5050, and that there is an open source library, luckily, on GitHub. I didn't have to reverse engineer the protocol and implement it. That's already good. And the way you use this library is like I showed in the snippet on the right. But basically, you can have your server and you can access the registers of your biogas plant controller. And so when you compile the biogas plant controller, you get a huge symbols list. When I say huge, like 1,000 lines of text where it's described, like register 1012 is going to be the gas pressure, and so on and so forth. I'm really grateful for Claude to exist or for any other LLM because I didn't have to go through this entire list by hand. I was able to ask it to. I inserted an old symbol list into Claude and I asked it to extract me the most important metrics and generate some names for it, and it happily did so. So yeah, that saved me some time. But before we were there, so we have this protocol. We can retrieve data inside the automation controller. But I don't want to write another Prometheus exporter in Python. That's what I had done. The links I referred to is the first iteration of the milking that data export. It was basically it was not good. I don't want to talk about it. Yeah, so no, I'm not going to write another thing in Python again. Instead, what I did is I implemented a gRPC service. I used connector PC. Who knows about connector PC? Oh, well, almost nobody. If you have to write protobuf or if you have to write gRPC, I really recommend checking those guys out. Connector PC lets you you can write gRPC. You can write your gRPC definitions and everything like gRPC, but it takes care of compiling that to protobuf and of providing all the software libraries that you need to run the gRPC thingy. So I use Connector PC. It simplified my life by a lot. I asked Claude to write me a protobuf definition. Well, of course, I had to rewrite it, but it was a very good start. And so basically, now I have my biogas plant, and I have a gRPC service, which I can then query with whichever language I want to get the data, or actually even to write the data on the automation controller of the biogas plant. And so the next step is that you have to write a Prometheus metrics exporter. I use the Victoria metrics library because it's quite simple and lightweight to use. So basically what I do, I collect the metrics with my gRPC client, and then I can just write Go code to create metrics, which is something I'm used to doing, and which is something which is relatively simple once you know how to do it. So we had the Saya PCD super old controller, then we have the SRS bus protocol, then we have this gRPC service. We can communicate with the gRPC service with a Golang exporter, and then we take this data. Victoria agent collects this data. It sees that it's long-term data. It pushes that to Victoria, and then we can have a nice dashboard for the biogas plant as well. So let's check it live as well. It's much funnier like that. So that's the actual power output of the biogas plant. So we see that we have only one motor turned on. I don't know why the second one is stopped. Perhaps there is some maintenance. We also see that the pressure in the digester is going up. We are at 1 millibar now. I've configured an alert, actually. I'm using Grafana Alert Manager, so built-in Alert Manager in Grafana, which is quite nice because then you directly see the alerting events in here. And when it sends an alert, it sends an alert to a Telegram channel where all the farmers are inside. And then with the alert, you directly get a screenshot of what's happening. So yesterday, there was an alert because we crossed 1.7 millibar of pressure. And so at the same time, they increase the power, someone manually increased the power of the engines. At some point, it would be nice to automate that, but for now, we already have the data. We have the temperature of the digesters, the volume, so how many cubic liters are consumed inside the digesters. When it goes down like that, that's because we are like on the post-digester, sometimes we take stuff out of it, so the digestate, the solid and liquid digestate. And when when you have a curve like that, it's exactly that process happening. So we are basically emptying some data, it's not data, some manure, some digestate, and so we can use it later on. So that's how I built the biogas plant dashboard. Then there's a simpler use case, but probably one of the most effective and useful one. It's the electric fence. So there are fences, like I said before, so the cows do not escape. I installed a simple Shelly relay. Shelly is a brand which produces automation equipment. And then I have an MQTT server on the farm, on the Kubernetes cluster. I'm starting to mix everything up. That's not good. So you have the Shelly device. It's connected to MQTT. Then you have Oham Assistant, which is connected to MQTT. And then the concrete use case is really valid. Whenever, for example, they are on the field, they see that the electrical wire is broken. Which means it's laying on the floor. You don't want to pick it up to reassemble the wire because then you take 20 kilovolt in your hands and that wakes you up quite quickly. So what you do, you take your smartphone, you just disable the fence, the electricity in the fence, you can repair and then you can turn it on again. So that's really simple use case, but really, really helpful as well. Then I said we have a milk vending machine. So also quite a simple use case. We have a milk vending machine, so you can go with your bottle, you can press a button and you get milk. What this didn't have is that the machine didn't have a way to alert you when the tank, because it's only a 40 liters tank inside the fridge, when the tank is empty. So I installed the LiDAR sensor on top of the tank, which measures how many centimeters of milk there remain. And the fun thing is that some smart people a long time ago figured out that 1 liter is equal to 1 centimeter. Yeah, so that's quite nice. And we also have the temperature of the milk. And yeah, I was talking about my long-term instance. Let's check that for the last 2 years. Okay, that's it. I have the data for the last 2 years, and we can say that we are not exceeding the temperature, except this time when the fridge was broken and we got an alert. So yeah, that's another use case. And then another use case is that I run Invoice Ninja, which is an open source invoicing software. So if you have to write some simple invoice or even complex ones, you can use this software here. And they use it for the stuff that they have to invoice. For example, they do silage work for third parties. They do also crop drying and stuff like that. So they have to sell invoices. Before it was done, well, Word and Excel document at best. And now they have a web tool where they can manage all their invoices. And they are really happy with it. And it runs on MariaDB. There are backups, so I'm also feeling safer knowing that all the invoicing data is not just on someone's hard drive somewhere place. It's MariaDB, it's backed up, it's on 3 sites. So that's also another use case I have for them. I think I went through the demos already. Some security considerations. Perhaps you can make the parallel if you have watched the movie Jurassic Park. One IT guy managing electric fences. I'm remotely controlling lift stock barriers. So yeah, hopefully no cars will escape. We'll see. At least they shouldn't eat anyone. That's already better than in the movie. Yeah, the lessons learned. The fact that I have these servers on premise, for me it's really a plus. I spare money. Well, I have to pay something, but it's much less than in the cloud. The performance is better than what I had in the cloud because on the cloud, it's a shared CPU that you get. And if someone starts to use the same server, you will see that's the noisy neighbor problem. You will start to have an impact on your workloads as well. Or that's something that you can tolerate if it's small workloads like this one. But if, for example, the cloud provider at some point screws up the disk change and pulls one live of an active bay that you're using, then for whatever you start to see that your cluster is down for 1 day, you're paying for that, well, afterwards they didn't charge the months in question. But like you also have incident on the cloud, so I prefer to have the incidents at my place. It's much more fun. The challenge, reverse engineering, this was a pain, really. Like the database, I'm not sure, do I still have the visualization software? Not yet anymore. But the database for the milking data, it's huge, and well, there's no documentation. You see some comments in some of the functions with some names and dates, it's fun, but you have to go through all the columns and well, reverse engineer what the guys who built the database did. Luckily, we have tools like Claude or any other tool which help you do that. So that made it a bit more tractable problem to have those tools. And I think that's the end of my session. So I'm happy to take questions on either Kubernetes or the cows. Thanks a lot.
Thank you very much, Clément. We have time for a couple of questions, I guess. Any questions for Clément?
Well, you could ask the name of cow number 22. We could check that out, but that's not. People are too hungry.
So how much do you charge your wife's family for your services?
I don't charge them. I don't want to charge people on the farm. I mean, it's also, I mean, she's also one of the co-owner of the farm. So if she makes money with the farm, I also get some money out of it. And I must admit also, we also have a freezer full of meat of the farm. We don't pay the milk, we don't pay the egg, the flour, we don't pay, yeah, it's free of charge. Hopefully, yeah, well, you couldn't charge a farm for just that. If a farm couldn't hire an IT department, that doesn't work like that. It would be too expensive. Hopefully, this gives ideas to people to do it as well on other farms. At least the tools are open source, but yeah, you still need someone who knows how to make those work.
Right, thank you.
There's one right behind you, and then there's another one behind.
How many hours did you invest until everything worked?
En français, we say, quand on aime, on ne compte pas. So when you love something, you don't count the hours. No, it's better not to know, I guess. Just behind you, there's another one.
Do multiple people have access to turn on and off the electric fence? Sorry.
Yeah. Yeah, there could be race conditions where people is on the wire and someone is turning it on. No, but it's only the farmers, they have access to the app. And no incident has happened yet. I guess if you see that it is down, and well, you shouldn't turn it on before asking anyone that there is maintenance or whatever. But that's a good point. I should add some information next to the thing that it has been like that for maybe 15 minutes. Then you know that someone is actively maintaining stuff. Yeah.
Good idea.
There's one at the back actually, so you have to show your throw skills. Oh, that's not bad.
Thanks. Have you thought about, generalizing this problem? I don't know if other farmers kind of have the same situation. I don't want to say commercialize, but I guess it would help a lot of people because these systems seem to be established, right?
Yeah, I've thought about it a little. There's likely a market, but perhaps I start at least a community yeah, that would be a good idea. At least start a community like the home ops community, like a farm ops community, and give some hints to people how they could start. Well, they should start small with Home Assistant MQTT. That's the first use case, which is helpful on any farm. And yeah, that's a good point. I should do that. Yeah. Thanks. There's one next to you, actually. No, it's just a joke.
So thank you very much, Clément, for your excellent talk. Let's give Clément another hand.